Good evening, everyone, and welcome to this webinar on decarbonizing our cities, innovation in heating and cooling. This webinar is co-organized by STEM Alliance, Scientix and Trane Technologies. My name is Aishwarya, and I work with various projects and activities with European SchoolNet. Together with us in the room today, we have Rocio Benito and Chanel Martinez, who will be supporting this webinar from a technical point of view. So in case you have any issues with the connection or with the audio, please feel free to send a message in the chat here. Let me continue with some technical aspects. This webinar, as we can see, is being recorded. We'll also see that all the microphones and cameras have been disabled. So if you have a question for our speakers today, just post them in the chat. And we'll have a Q&A session towards the end of the session today. So we will take all your questions and we'll address them to the speakers. You'll also find that during the session today, we'll be sharing many useful links and information. So we encourage you to open the chat and take a look at them to get the most out of the webinar today. And we've already shared the first link with you today. So this is the signature list. So this is an important link to validate that you attended this webinar. This is also to prove that the event took place and we can continue to organize events like this. Also, if you're interested in receiving a certificate of participation, this is the only way to request one. So we will give you maybe a minute to fill this out. Okay, so now we can move on to the agenda for the webinar today. First, we will have the speakers introduce themselves. It's my great pleasure to have Marie Dunn with us today. Thank you for being with us. Also, so she will do the first part of the webinar today, that is Introduction to Trane Technologies. That will be followed by Heating and Cooling of Buildings by Ronald Herbst. And then we'll finally have Transport Refrigeration by Yesuhel Gonzalez. After which we'll have a Q&A session and we'll finish with the closing remarks. The floor is yours, Marie.
Thank you very much, and good afternoon and good evening, everybody. First of all, I'd like to say thank you to Scientix and European SchoolNet STEM Alliance for inviting Trane Technologies to speak today. We're delighted to be here with you to discuss a topic that's very close to our hearts. My name is Marie Dunn. I work as Vice President of IT at Trane Technologies, supporting our commercial HVAC and Thermo King businesses in EMEA. Today, my fellow colleagues from Trane Technologies and I want to share a message about what's possible in transforming STEM education and the green transition in schools. There's no doubt that schools play an important role in engaging students and the wider community on sustainability concepts and developing the skills needed for a sustainable society. There's also no doubt that companies like Trane Technologies can help bridge the knowledge gap to what's happening in industries like ours. This close connection between schools and the industry will have a positive impact on the environment and innovation towards sustainability, while also developing highly skilled STEM students who will lead innovation in this area. And it's never more important than in Europe today, where we just heard about the warming of our region at twice the global average. So really dear program for us all. Our company is already playing a role in helping with the content of educational programs. We have a program called Sustainable Futures, which has a clear goal of uplifting underrepresented students to give them access to STEM and green careers. And I'll share more about this in a few moments. And teacher education is key, and we're wholly committed to investing through partnerships like this. So our speakers for today are Ronald and Yesuhel, and I'll let both of them introduce themselves in a couple of minutes. And before we go to a short video, I'll give you a little bit of background on me. So I've been with Trane Technologies for over 24 years. It's harder to say that every time. I'm based in Galway in Ireland, and I started my career as an accountant graduating from University College Galway and then completing my CPA with the Institute of Chartered Accountants in Ireland. As part of my finance role, I became involved in an IT project on a temporary assignment for about 6 months, and that was 20 years ago, and I've been in IT ever since. I'm really fortunate to have worked with many different parts of our Trane Technology business all over the world during this time. And I think in the 20 years, I've had over 15 different roles, and I'm very grateful to Trane for the endless learning experiences it continues to provide. One point to note is that in all of this time, I've only had one female manager. That was my very first manager. So it's another reason why STEM education is something that's very close to my heart. So to start, we're going to have a quick video to talk about and share a little bit about sustainable futures.
When you look at things from a different perspective and examine them from a new viewpoint, studying the macro and micro from a place of knowledge and commitment, then the ordinary can be made extraordinary. And anything is possible. As a global climate innovator, Trane Technologies is committed to creating a bolder, more sustainable future. Today, many children around the world lack basic resources to excel in school and in life. They are missing necessities like healthy food to fuel their bodies and clean air to improve wellness in their classrooms. At Trane Technologies, we're dedicated to changing that. We believe that there's no better way to uplift our communities than by helping students, by making sure they have a sturdy foundation to learn and the tools they need to propel themselves toward rewarding careers. We partner with talented nonprofit organizations, and together, we are stimulating students' appetites for learning and exploration, teaching them concepts around science, technology, engineering, and math, providing enriching experiences, introducing them to the exciting possibilities of green and STEM careers, and supporting their journey to rewarding and sustainable futures. We have always believed that it is our responsibility to use our resources to make life better for young people and for the communities they call home. Now, through our corporate citizenship strategy, Sustainable Futures, we are investing $100 million and 500,000 employee volunteer hours by 2030, providing meaningful resources to uplift underrepresented students from elementary school to vocational school or college. We'll give them access to tools that take their learning beyond the classroom and into robust internships with real-world hands-on exposure to the surprisingly diverse assortment of rewarding green and STEM professions. Everyone deserves to dream big dreams, to explore, test their limits, and ultimately to succeed. According to World Inequity Database on Education, in 58 out of 133 countries, fewer than half of young people have not completed upper secondary school. We know that careers in the green and STEM fields are growing and pay a living wage. By first shoring up students' basic needs, like food and air quality, and then building pathways to solid careers through early education, vocational certifications, and four-year degrees, we are providing young people the opportunity for better lives and helping to create a better world, one in which no one goes hungry. Then we all will contribute and play an important role in our climate's and the world's future. We can show people what's possible. It is our commitment to contributing to the quality of life and opportunity for all, and being a global climate innovator. We have the know-how, we have the technology, and we have the people. At Trane Technologies, we are here to challenge what's possible for a more sustainable future.
Okay, so hopefully you're all feeling uplifted after that interesting video, and lovely to see all the smiling faces. Okay, so let me introduce Trane Technologies to you. You heard a little bit about us in the video, but our purpose is to boldly challenge what's possible for a sustainable world. We're a global climate innovator who, through our strategic brands of Trane and Thermo King, and our portfolio of environmentally responsible products and services, We bring efficient and sustainable climate solutions to buildings, homes, and transportation. Our history goes back many years. Trane was incorporated in 1913 and Thermo King was founded in 1938. We've 37,000 employees globally and growing, and we've got 150 different facilities in EMEA alone. We're listed on the New York Stock Exchange, and our stock ticker is TT for anyone that's interested in following. So on this slide are global megatrends. So we know the impact that we can have as a company because the data shows us. 15% of the world's global emissions come from heating and cooling of buildings. 10% of the emissions come from food loss and waste. So innovation in our businesses can contribute to 1/4 of the world's greenhouse gas emissions. So we are on a journey to change an industry, and by changing an industry, we can really change a world. These numbers really outline how that is possible. So we've been on this journey for some time. Trane Technologies set ambitious sustainability commitments for the year 2020, but we actually achieved those commitments 2 years earlier than planned in 2018. We now have a new set of commitments for 2030, which involve reducing emissions of our customers, achieving carbon neutrality in our own operations, and providing opportunity for all, which is where our sustainable futures comes into play. Clean technologies and electrification play an important role in both parts of our business. Electrification of heating in buildings to remove fossil fuels, and we'll hear a little bit more about that from Ronald, and electrification of transport refrigeration, amongst many other initiatives, innovative, clean technologies to heat and cool buildings and move food and medicine safely around the world in sustainable ways. And finally, a little bit more about our Sustainable Futures program, which aims to uplift our underrepresented students through education and pathways to green and STEM careers. We're very proud of the work our company is doing in this space. The objectives of our programs, as seen on the video, are to help students understand the world of STEM, the impact to their world, and the actions they can take to be change makers. Grow the next generation of STEM leaders to fill the jobs of the future. Seeing all the smiling young children in that video really outlines how this is possible, and showcasing Trane Technologies as a leader in sustainability and innovation and a great place to work for STEM. So with that, I am going to hand you over to Ronald, who's going to share a little bit more about heating and cooling in buildings.
Okay, thank you. So my name is Ronald Herbst, and as you can see, we are, and I am very much involved in the heating and the cooling of all kinds of different buildings that we have across our region, which in my case is Europe, the Middle East, Africa, and Australia and New Zealand. So, slide. Second, doesn't move. So in my current role, I'm a product manager for many cooling and heating products. So they embed, let's say, the chillers, the heat pumps, the multi-pipe units, which I will touch on a little bit later on. But where I started was, let's say, with going to the University of Applied Sciences, and where I graduated in 1988. So, and pretty soon after, in August 1988, I started to join Trane in the Netherlands as an HVAC systems sales engineer. My specialization in the university was thermodynamics. So there was a pretty good fit, let's say, with starting to work for the Trane company in the Netherlands. I worked there for over 12 years, and I left Trane in the Netherlands as a general manager, where I was leading the business for a couple of years. And then I moved in the year 2000 to the headquarters. The headquarters in those days was located in Amsterdam, so pretty close to, let's say, the place where I live. And in there, I worked there for 11 years, and I fulfilled all kinds of different business development roles. Then another important thing, let's say, in my career was the fact that I got the opportunity to represent Trane Europe with the EU governmental affairs role in Brussels. And so then in those days, in 2011 up to 2014, there was a lot of, let's say, challenging European legislations, which were in preparation. And we were able, as a company, to have a serious work in what can be done. So what kind of bold challenges that we were able to fulfill in the HVAC equipment, energy use, the carbon emissions, and the waste reductions. And of course, that was embedding all, let's say, kind of sustainability into all major facets of the Trane product development process. Then, starting from 2014, and I'm still in that role today, it became a product management role. And what I think is important, so even after, let's say, 8 years in that new role in product management, is that I always continue to focus on a balance between comfort for building owners, building users, affordable, sustainable HVAC solutions, clean air, and responsible use of all the resources. So on the next slide, so on the next slide, you see there are in fact 3 pillars for sustainable solutions for HVAC installations in buildings, whether it's from residential to non-residential to industrial buildings. One, the first bullet point is the energy efficiency or the energy avoidance. The second one, and Marie already touched on that, is the electrification of heating, which is today's topic. And the third one is the use of low up to ultra low GWP refrigerants. So for the next 10 minutes, I will try to, in a very simple way, explain to you how the electrification of heating could function with an air-to-water heat pump as an example. So when we think about how we cool ourselves, we have to realize that when the sun is really hot, so when the heat is really on, we sweat to keep ourselves cool. We transfer water from inside the body to our skin, and there it starts to evaporate. And that is going to make the skin cooler. So keep in mind, when you evaporate water or any other type of fluid, it starts to create cooling. If you think about a refrigerator, which you have at home, the refrigerator is cooling your food and your drinks, and you see it on the left side of this slide. And how does a refrigerator function? In very simple words, it evaporates a liquid which is flowing inside the refrigerator so that it cools down the air inside the refrigerator. This evaporated liquid, which we call in our, let's say, industry refrigerant gas, is pumped by a compressor to the backside of your refrigerator at home. And there it starts to heat the kitchen. And why is it heating, let's say, the kitchen? Of course, very small, but because it takes out heat from inside the box, inside the refrigerator, and it moves the heat to outside of the box. And that is done through a refrigeration cycle. So inside the refrigerator, you will see the temperature going down. While if you put your hand on the backside of the refrigerator, on the condenser side, you will feel that it is warming up and that it is starting to emit heat to your kitchen. So what if you would want to cool your house? With that, we can think about an air conditioner. And an air conditioner is like a refrigerator for your house. It cools the inside of the house and it rejects heat to the outdoor air, to the ambient air. So the temperature inside the house goes down, while we emit the heat outdoors. If you think about what would happen if we reverse some of these air conditioner components, what could happen? Well, we cool the outdoor air and we start to warm the house. So you see the temperature inside the house going up while we are taking heat from the ambient air. And keep in mind that in ambient air, outdoor air, there's always heat available. There's always energy available. And we are going to use that as our heat source while heating the house. So when we think about when we can warm the house in this way, we are no longer burning any fossil fuels. So there's no gas that needs to be used. And we can also stop the chimney polluting the air we breathe. So with an air-to-water heat pump, and I just take the example because it's an easy example, the air-to-water heat pump, over time in the city centers and in, let's say, the suburbs where we all live, we will see no longer chimneys and there will be no emissions through the chimneys to the air that we breathe close to the place where we live. And you see, when the temperature inside the house goes up, the energy, the heat that is available in the outdoor air is going to be transferred to the inside of the house. It's clean and it's 100% renewable. So an air-to-water heat pump can generate hot water by taking that heat from the outdoor air. I started to talk about an air-to-water heat pump, but in fact, when you summarize this, there are many more heat pumps. The heat pumps can extract heat from outdoor air, from groundwater or lake water, and deliver it elsewhere in a house or any non-residential building, like for example, a school. And this transformation of heat from outside source to the indoor source is done via a refrigeration cycle, which is very similar to what you see happening in your refrigerator in the house. The energy comes from natural heat sources. So like I said, the outdoor air, the groundwater, the lake water. It is endless and it is renewable. But what about energy efficiency? And because we are all used, let's say, to heat up our houses and our buildings with gas boilers and oil boilers. Well, if you summarize it in just 2 bullet points, with 1 kW of electricity used by an air-to-water heat pump, you can deliver approximately 3.3 up to 3.5 kilowatt of heat. So the energy efficiency is around the 330 up to the 350%. When you think about more traditional heating technologies, like for example, the best-in-class actual gas boiler, that has a maximum efficiency of 96%. So you see significant difference in how energy efficient the 2 different heating technologies function. When you think about, let's say, direct electric heating, the situation is even more favorable for the air-to-water heat pump because direct electric heating systems, in average, they have an efficiency of 35 to 45% maximum. So when you summarize it, the heat pumps, they are making optimal use of renewable energy sources. It's full electric, and it will deliver much cleaner air in our city centers. So what is a heat pump in very simple words? If you just summarize it, it consists out of 4 components. That is the heart of any heat pump. So there are 2 heat exchangers, there's 1 compressor, and there's 1 expansion valve. And you see there in the middle of your screen, you see those 4 components, let's say, reflected. And there is gas and liquid, which is a refrigerant, flowing around in that closed loop. To not make it too technical, what you see happening on the left side is the evaporator. So a liquid which transforms into a refrigerant gas in a gas phase. And so you go from a liquid phase to a gas phase. And that is the result of the heat that is taken out from the outdoor air or the groundwater or the lake water. And that heat is, let's say, transitioning to the liquid. And it's taken up by the liquid, so it evaporates. And then you see the refrigerant gas starting to flow around. And the compressor lifts it from low pressure side to a high pressure gas. On the other side, you see the heat exchanger where the arrow goes out with the hot water. In that heat exchanger, which is a condenser, the heat from the refrigerant gas is going to be transmitted to the hot water that flows through a closed water loop. And that closed water loop, with the higher hot water temperature coming out of the heat pump, is going to feed the radiator in the house or the underfloor heating system. And that helps you to raise the temperature inside your living room or bedroom or whatever. So this is in very simple words how a heat pump is construed. So always keep in mind there are 4 key components: 2 heat exchangers, 1 compressor, and 1 expansion valve. Talked a lot about, let's say, residential, non-residential buildings, but there are also industrial buildings with more industrialized processes. One of the processes that I would like to show here to you is how we are helping the milk manufacturers to turn raw milk into processed milk. So it comes from the cow and it ends up in a bottle of milk. Yeah. For that, and most of you are probably well aware about this process, there is a milk pasteurization process. And that ensures that it will be safe to drink a bottle of milk. Why? Because in raw milk, you can have very dangerous bacteria, and that can pose real serious health risks to you or to your family. And of course, through the pasteurization process, we would like to kill those bacteria to really make the milk very safe to drink. In most milk processing plants, the raw milk is heated until it reaches approximately 72 degrees Celsius. It's then held at that high temperature, so the 72 degrees Celsius, and that for at least 15 to 20 seconds. And then in the process, it's cooled down very quickly. So it goes from a level of 72 degrees Celsius down to a level of approximately 4 degrees Celsius. In a traditional milk factory, the pasteurizing, and I just gave here a couple of numbers to make it, let's say, more tangible. We needed 100 kW of fossil fuel, most of the times gas, to deliver the 100 kW of heating needed for the pasteurization process. But after the pasteurization, the last phase is to cool it down. And for that, you need another 100 kW. So, and that was mainly done with a chiller. And the chiller was using approximately 30 kW. So to get the whole process from A till Z, we needed approximately 130 kW of energy input. 100 kW coming from gas boilers, 30 kW coming, let's say, from electricity, from the power plant. By using, and you see in the middle a picture of such a water-to-water heat pump, we are able to regain and reuse the heat coming from the milk cooling process. That regained heat is going to be reused to heat up the milk in the pasteurizer with one single unit. And as you can see, there are no gas lines connected to this one single unit. It's a water-to-water heat pump. It is connected to the power grid. So with the 30 kW that you also remember from the previous slide, we have sufficient power to run the whole process. A process which can deliver the 100 kW of cooling, as well as the 100 kW of heating needed for the pasteurizing. So if you summarize this is a 77% energy saving. So we went down from 130 kW of energy use to 30 kW of energy use, which is all electrical. So going forward in the coming years, and we already have many projects realized, but there are many more to come. You see that the clear trend is that we move away from gas and oil fueled installations to fully electric installations. And now in most countries, there's a strong trend that our power generation is becoming powered by all kinds of, let's say, renewable sources like the windmills and solar power and tides, etc. We will have, let's say, fully renewable energy that we are starting to use for these type of industrial processes as well, besides everything that we do in non-residential buildings and the residential buildings. Well, I hope this was interesting for you. Before I hand over to Jesuel, we have a very short video, which is, let's say, dealing with how electrification of heating, how it happens today, and what kind of products that Trane Europe, Middle East, Africa has developed a couple of years ago to really help, let's say, pushing this trend into the business and into our lives. So thank you for listening. After the video, Jesuel will take over and enjoy the video.
To transfer refrigeration. Let me talk a bit about myself. And I'm going to get closer because the screen is very small and I'm a little bit blind. So my name is Yasuhel Gonzalez. I am Mexican, and I'm the PMO leader of Thermo King EMEA business unit. PMO stands for Program Management Office. So just to summarize it, we're in charge of executing the projects to come to new ideas and new products. Let me tell you a bit about the role specifically. So, okay, apologize in advance. I will be coughing through the presentation. Sorry for that. Part of the things that we do in the department, and I don't speak just about myself, but the full department, is supporting the prioritization of ideas. So you can imagine that we have ideas for new products coming from anyone, really. You know, any idea is a good idea, right? But we need to decide when it makes sense to implement something, when it makes sense to maybe push it for later, if we need more information and so on. So we need to run these ideas into projects. And this is taking into account the needs of the SBU. So what do I mean by that? Sometimes we need to focus on short-term projects, so projects that are going to give us some benefit on the short term, and sometimes we need to focus on projects which are more strategic and are going to give us some benefits on the long term, right? So ideally, we want to have balance of these two, so short term and long term, to be able to thank you, Geraldine. Yes, SBU is a strategic business unit. I will try to not say acronyms, but the full word. So we always try to have this balance, right, on the short-term and long-term needs. One of the main tasks as well from my team is to execute projects, as I mentioned. So it's, you know, it's like a dance. I call it a dance because we have always these three constraints. We have quality, scope, and time. Sorry, quality, cost, and time. And it's a dance because it's not easy. So all throughout the project life cycle, we have to be playing with these three plates and trying to make sure that we deliver the project on cost, on time, and on quality. And when sometimes you have to focus much on one of these and you have to disregard the other. So it's a dance. That's why I call it that way. And last but not least, it's about improving processes. So we have a world of standard work to support our processes, to know what we need to do and what are the steps to deliver from A to B a product. But the world is continuously changing, right? So what was working before might not be working now. So it's our job as well to evaluate if the environment has changed and if we have to change our processes as well. So in terms of my career path, I already mentioned to you, I come from Mexico. I'm a computer systems engineer. So opposite to Marie, I didn't work much on the IT world, only a couple of years, and then I moved to the aerospace industry. I worked in Mexico as a design engineer, then a technical expert, so pretty much all on the technical world of the wiring harness of the airplanes. And then I decided that I wanted a change. I wanted to further my career and learn more than just the technical side of it. Sorry. And I decided to do a master's degree in global innovation management. It was a joint degree in the University of Strathclyde in Scotland, Glasgow, and Hamburg, TU in Germany. So it was a 2 years master's. And when I finished the master's, I decided to stay in Germany for some years. Again, in the aerospace industry, working for Airbus first as an engineering manager, and then I moved to this world that I'm in now, program management. For a little over than 7 years, I stayed in Germany. And then we decided as a family that we wanted a little bit more sun and that we needed some warmer weather. And that's the reason that we moved out from Germany. I am now based in Barcelona. I joined TK in 2018. And one of the reasons I joined TK was because I was very excited to be leading one of the electrification projects. As Ronald already and Marie, they both mentioned electrification is one of our focus, right? So I was very excited about these sustainability targets. And so I was leading projects at the beginning, and then since 2 years ago, I'm the PMO leader of the department. Why I like this job and why I like this world, I would say it's first because it's very transversal. So I really get to work with almost everyone from the company. The beginning, the project has certain needs, right? So you're talking more about what should the product do, what kind of requirements, and then at the end, you're all about industrializing it and making it ready for launch. So it's very different, the conversations and the kind of work and the pace and the activities, and it's so transversal that it makes it very enriching for myself. As well, it's very diverse in the sense that I don't just see trailer products, for instance, or I don't just see truck products, but I really get to see all of the range of products, and that makes it very interesting. And as I mentioned before, the sustainability focus that the company has, it makes it very, very interesting and exciting to be part of. These are my hobbies that I'm mentioning there. I don't have much time to do them because I have a 9-month baby. So pretty much the first one is the only one that I get to do family time. All the rest are my hobbies, but I don't have time to do them now. So, okay, that was just a little bit about me. The way I prepared the presentation, I was thinking, okay, I like to explain to you a bit of the process that we follow to create a product, right? So to the process that we do to make a project a product. And then I will go very, very, very superficially into the technology. I'm not the expert on thermodynamics as Ronald is. I like to show you the difference with transport refrigeration. And then putting these two things together, I like to show you how we're giving value to the customer, right? Because in the end, all of these things, we're doing it to provide some value to the customer. So let me move to the next slide. Okay, what is the process that we're following to create technology in thermocline? We have a gate process. So it's called a gate process because there are milestones that every project is going through. And at this milestone, it's always like an audit. And we say, okay, is this project good enough to continue? Is it ready? Do we want to move on? So the first gate is gate 0. And what we ask ourselves then is, it's just an idea, right? By then it's just a preliminary idea. And we ask ourselves, is this an idea that is worth exploring? If the answer is yes, then we move on to the concept phase. We draft a concept, still very preliminary, but a little bit more detailed than the idea. And then we go to gate 1. And then we say, okay, do we have a commercial hypothesis that it's sufficiently attractive to move on to validating? If the answer is yes, then we move on to the next phase, which is the phase 2, and we validate the concept. Now, the gate 2 is a very interesting gate. We call it one of the most important because it's the gate where, where commitments are made. So the team is committing to deliver this product at this time, at this cost, with this quality. It's like, you know, we always, through the life of the project, we'll always come back and compare versus these gate 2 commitments. So if the gate 2 is approved and we say we have validated the commercial hypothesis and everything is good to go, then we move to the phase 3, which is the detailed design and the validation. So gate 3, when we go to gate 3, we should have a frozen design. It's like, okay, this is the design that we're going to manufacture and we're going to be selling. It will not change anymore. If we go to gate 3 and we confirm that it has been verified and we're comfortable with the quality of the product, then we move on to the phase 4, which is the preparation of the launch. And this is more really going into the operation side, into the manufacturing plants that get ready to start really the production of the product, right? So we go to gate 4. Gate 4 is then the SOP. SOP is the start of production. And if we are all good to go, then we will launch. Once we launch, we give ourselves some time. It can be from 1 year to 2 years, depending on the project, to give it time to behave right in the real world and see how it's doing, and then to compare it versus what we had committed in gate 2. As I mentioned, we always see, okay, how well we did, what did we miss, what can we do different next time, and yeah, all the learnings, right? So that's pretty much the process, and it's quite standard. We follow it for almost every project, regardless of the platform it is, regardless of if it's trailer, if it's bus, or if it's truck. We follow this process generally for every project. So this is the process for project management. And this is, let's say, what my department is doing, right? But then let me go a little bit into the technology itself of transport refrigeration. And I think in a summary, it's similar to what Ronald was explaining before. The main difference is that we're talking about transport refrigeration. So it means that we are talking about something that is transported. So we cannot get rid of heat, we don't destroy heat, but we want to move it. So in this case, we want to move it from inside the box to outside the box. What Ronald was saying was the opposite, right? He was about heating inside. So we want to take it out. And where is this heat coming from in our boxes? It can be, just to clarify, box can be a box that it's maybe, attached to a trailer, attached to a small van, like boxes which are smaller attached to a van. Can be one that it's transported in a container in an airplane, or It can be also the buses are transporting passengers. So anything that it's transporting, this is what we would be falling into this category. Okay. So where is the heat inside the box coming from? And it can come from different sources that I'm listing here, the main ones, right? So the first one is the radiation from the sun. The waves of the sun are hitting the box, and slowly it's entering into the box. If you might have seen in the roads that the trailers or the trucks, the box is normally white or kind of a metallic color, because the idea is that it reflects the sun. So then it's, this transfer is not as fast, or it's as slow as possible. Then another way that heat is coming into the box is that when it's the most common one, I would say, the doors opening. The longest that the longest that the door is open, or the more times that you're opening the door, the more heat is coming in. And you have this situation, I guess, in your houses as well when you're opening the fridge. That's why we have these alarms to let us know that it's open, right? We don't want to have it open a long time. It's bad for whatever is inside the box. It can also happen that we have some leaks inside, or the insulation is not properly done, and then you have some leaks. But I would say that it's mostly coming from the door openings. And then the other source of heat in the boxes is the one that is generated by what's being transported inside the box. So it's called heat of respiration, and not everything has a heat of respiration, but there are some foods that do. For instance, the asparagus and the strawberries are some of the typical ones that have a high heat of respiration. And as since they're kind of like a living organism, right? So as they are getting riper, they are producing this heat. So it's being condensed inside the box. So, not to go too much into detail, you will see that the 4 components that Ronald was saying before are the same components that you see here. The compressor, the valve, and then you have the 2 heat exchangers. Now, what happens in the system is that the refrigerant is constantly going through this closed loop. So it's always going. The compressor is pumping the refrigerant. When it's on the right side, on the red side, it's being pumped as a vapor, and it's releasing the heat into the air. So when it's releasing the heat into the air, it's becoming liquid. Then it continues its row through the different, the different, how shall I say, path of the circuit. It goes then inside the box. The part of the blue part is inside the box, the red part is outside the box. When it goes inside the box, then it's in a liquid state and it becomes vapor again, as what Ronald explained before. And when it is vapor, it is absorbing the heat from the box. So it is continuously going from vapor to liquid, liquid to vapor, releasing heat, absorbing heat, releasing heat, absorbing heat. So it's pretty much the same, but it's inverted from what Ronald had said. And besides these 4 main components that were already mentioned before, I can say that maybe the 5th component that is worth to mention is the refrigerant, that it's acting like the blood of the system, to call it in a way. And this system, it's typical in any refrigeration system that you would see, like in a bus air conditioning or in the groceries storage, the freezers that you have in the groceries, in your fridge at home. So it's a very similar technology always. Why I wanted to show you this, it was just it was very basic, because in the end what I want to put together is we have projects, we have technology. In the end, we want to put this together and help our customers. So what do we do with this? And I'm going to focus only on the first 3 for now, on the regulation part, on the connectivity, and on the sustainability. So on the regulation side, I'm going to talk here about the reduction of food loss. It's a crime to me, how much food is being wasted. We're almost 800 million of people, and it's known that 1/3 of the food that is produced is being wasted. So it's a crime on the greenhouse gas emissions, because it's pollution, but it's a crime because it's just food that is not eaten. So it shouldn't happen, right? Or we should at least try to minimize it as much as possible. And it's known that obviously food loss is not always because of cold chain, but at least 25% of this food loss could be reduced if we apply the right technology of cold chain. And this is one of the ways that we support our customers. I have put an example of the asparagus, because the asparagus is quite a sensitive product. So if you just get it wrong by 2 degrees, so it should be normally stored at 2 degrees. And if we get it wrong and we stored it at 0 degrees, it goes all black and squishy, and then you cannot eat it. So it is very key to have really good control of the temperature of the food that it's being transported at all times. So that's on the food loss part and regulation part. Then on the connectivity side, how do we help our customers? You know, digital is everywhere, right? We all have our phones and we're connected and we want to have information at all times. So we want to give this to our customers as well. Now, this is the same system that I showed before. Oops, sorry, I wanted to play this. Can I play this? Well, it doesn't, okay, never mind. It's just a small video with the circuit going on. It's the same circuit I mentioned to you, but with some additions. We have added sensors inside the box so that we can know exactly the temperature at every point of the box, not just, you know, where you're pumping the air, but you want to know what's the temperature at the end of the box as well. And we want to know where the box is, right? We want to know the GPS location. We want to know how many times the door has opened, for how long the door was open. We want to know the route that the truck has taken to see if it's more efficient. We want to know how much diesel it has consumed. So all of this information now we are able to provide to the customer. Before it was really rudimentary system that it was just refrigerating. You didn't know if it was really well kept. And now we can provide all of this information. We can even tell even the driver or the fleet manager, look, you have driven for X amount of days or hours, then you should go to maintenance because probably this component could be breaking. So this is the part of digitalization and connectivity. And then the last part I will be touching base is on the sustainability. Somehow I cannot play the videos inside. But okay, I'll summarize it for you. We were the first company to introduce the R452A, which is a refrigerant that has a lower global warming potential. This has been great because we're talking about a great reduction on the environmental impact. Another thing we're doing, and Ronald already mentioned it, and we're doing it also in transport refrigeration, is to go for electric units. So electric units save fuel, but also they are quite much quieter. So you know that if you compare any device with an electronic device, they're all normally much quieter. So we're able to enter into the urban cities and the urban centers because there's not so much noise. Sorry. And then there's the option that it's a hybrid, call it a hybrid. So you go with the diesel system from one city to another, but when you have to go into the urban centers where there's this low emission zone regulations or ultra low emission zone regulations, then it switches to electric. And then you can go inside and it doesn't bother the people and it allows you because the regulation allows you. So there are a few things that we're doing. We're not stopping here. We want to continue to search for even more lower GWP refrigerants. So this is really our challenge, and we are all very, very invested on this. It's very exciting. I think I would say very exciting times. And this is just an example of the technology put to work in a real life. So this is a trip that is from Denmark to Italy. We're transporting fish here. Don't ask me what type of fish. But in 2019, with our trailer units, we would have used almost 300 liters of diesel. And now in 2022, with our new TK Advancer unit, we would reduce it by 40% the fuel consumption to 177. So to me, this is amazing because we're talking just about 3 years and the difference on the impact that we can make is huge. And obviously it's great because we're giving this value to the person that is buying the refrigeration unit. So this person is saving money and that's always good. But we're giving value to someone that is not even linked to the refrigeration transport because we're saving, right, CO2 emissions, and that's the most impactful for me. So try to go fast because there were too many slides. There's one small video at the end, but because I see that we only have 5 minutes left, should we go ahead and go for the Q&A section?
Yes, I think we can move on to the Q&A session. So we have just about 4 minutes to go. Yeah. Anyone? So we had a question sometime back from one of the participants here, and Geraldine has answered the question. So I invite everyone to go through what Geraldine has said here. It's a lot of interesting information with links.
Yeah,
Do take a look at this.
Maybe to summarize, the question was, what ideas can we provide for schools, project ideas for schools? So Geraldine has shared that we will be providing some heating and cooling experiments that students and teachers can lead in the classroom, and we've done this actually in North America as well. I was involved in some of these experiments, so really interesting, and we'll be sharing more. And also these slides and the videos can be presented by teachers to students in their classrooms. I personally found Ronald's explanation really helpful, because today we hear so much about heat pumps and in all across Europe, and it's really new technology that's really exciting for decarbonization. So hopefully Ronald's explanation will help more of our teachers and students to understand the technology. So these, and also Yezahel's explanation and videos may be helpful for teachers to take back to the classroom.
Thank you. And I would also like to thank all the speakers today for sharing your stories. I found it very interesting to listen to your career trajectories. That all three of you come from very different places, but all of you now work in this organization towards sustainability. I think I'm sure the participants enjoyed all the information about science and how refrigerators work. I was particularly intrigued by the air to water heat pump. I found it interesting. So thank you once again for joining us today. Before we close the session today, this is a reminder for all the participants today to register for the Scientix conference. So we just have a few days left before we close the registration here. So please do take a moment and take a look at this. And finally, in case you have not signed the participation list yet, this is the only way to get a certificate. And it's also a way for us to keep doing these events. So we invite you to fill this in case you have not. And yeah, thank you everyone for joining us today for this Trane Technologies webinar organized by STEM Aligned Scientix. And we look forward to seeing you again at our next event soon. Have a great evening.
Thank you
very much.
Thank you.
Bye-bye.
Bye. Great evening.
Bye-bye.
Thank you. Bye, everyone.
Bye-bye.